The night is silent, the stars are steady, and then, without warning, the sky fractures. A streak of white light tears across the heavens. Dust ripples through the atmosphere. People look up and realize they are watching the impossible unfold. The moon is breaking apart, not drifting, not cracking slowly, but shattering, instantly, into colossal fragments. This is where the story begins. At first, no one understands what has happened. Telescopes swing toward the sky, capturing a scene that defies imagination. The familiar gray sphere is now a halo of drifting debris, massive shards floating in silence, like the remains of a destroyed world. Some pieces are the size of mountains, others are continents of stone. A few glow red, hot, freshly torn from the lunar core. Billions of smaller fragments scatter outward, forming a rough, uneven ring around Earth. Beautiful, but deadly. The cause of the break is unknown. An asteroid impact, a sudden collapse, ancient fractures finally giving way. The reason doesn't matter now, because the moment the moon shatters, Earth begins to change. The first consequence arrives immediately. Gravity itself becomes unstable. For billions of years, the moon has guided Earth's tides, steadied its rotation, and anchored its seasons. But when the moon becomes a cloud of debris, its gravitational pull scatters across thousands of pieces, uneven, unpredictable, chaotic. The oceans are the first to feel the change. Tides surge without rhythm. Some coastlines empty out suddenly, exposing miles of seafloor. Others are hit by violent, unexpected floods. Ports, coastal cities, and fishing towns around the world face devastation within hours. Earth's tilt begins to wobble, not by centimeters, but by degrees. The moon has always acted as Earth's stabilizer, holding our axis at 23.5 degrees. Without it, the planet becomes unstable. Seasons stretch and compress in strange patterns. Summers grow longer, winters become harsher, global weather begins to warp into unfamiliar shapes. Earth has lost its cosmic anchor. Then comes the sky. Within days, the fragments of the moon spread into a massive debris field. To the naked eye, it looks like a glowing belt of pale dust, haunting, shimmering, and strangely beautiful. But danger hides behind that beauty. Earth's gravity begins pulling fragments inward. The first pieces burn up harmlessly, lighting the night with bright streaks. But as time passes, larger pieces enter the atmosphere. Fireballs blaze across the sky. Air travel grinds to a halt. Meteor detection systems overload. And humanity realizes that this is not a meteor shower. This is the moon, falling home. The larger fragments stay in orbit, but they collide with one another. Some shatter further, adding to the debris cloud. Others begin decaying toward Earth, each one a potential catastrophe. A single fragment could hit with the force of a nuclear explosion. A larger one could level a continent. To understand what comes next, we look to history. Earth has experienced massive impacts before, but not in the age of civilization. The moon itself was born from a collision between Earth and a Mars-sized world, but humanity has never lived under a sky filled with thousands of potential impactors, nor have we ever experienced rapid tilt shifts in real time. Without the moon's stabilizing pull, Earth's tilt could swing wildly over geological timescales. But now, that shift accelerates. What should happen over hundreds of thousands of years begins unfolding over decades. Humanity faces a global transformation at a speed never recorded in nature. Life on Earth begins to adjust. Ports are abandoned. Coastal settlements move inland. Agriculture struggles as seasons grow unpredictable. Power grids strain under massive storms. Satellites are damaged or destroyed by high-speed lunar debris. Nights grow brighter, illuminated by countless drifting shards. The familiar phases of the moon vanish. Instead, people see a broken necklace of glowing fragments orbiting the Earth. Human culture changes too. For centuries, the moon has been a symbol of mystery, romance, mythology, and timekeeping. Its cycles shaped our calendars, our tides, and our imagination. Now that face is gone forever. Humanity begins searching for meaning in a sky that no longer matches its stories, then the worst fear arrives. Months after the shattering, a fragment the size of a skyscraper begins falling toward Earth. Scientists predict an impact somewhere in the Pacific. The energy would be equivalent to several nuclear detonations. The tsunami could cross entire oceans. Evacuation orders spread across continents. Nations unite to attempt a desperate interception. Multiple rockets launch at once. Their goal simple: push the fragment off course. The world watches. Some rockets succeed, some fail. The fragment splits, creating several smaller pieces. Most burn up upon re-entry, but one hits the ocean. The impact reverberates across the Pacific, triggering a massive wave. Hours later, it crashes into coastlines around the world, reshaping shores and altering ecosystems forever. Humanity survives, but the message is clear. As long as the moon remains shattered, Earth will never be the same. Years pass. The debris ring slowly thins as fragments burn up or drift into deep space. Earth stabilizes slightly, but the weather remains more violent than before. Tides settle into new, unfamiliar rhythms. Human civilization adapts, reshaped by a sky that reminds us how fragile our world truly is. People still look up at night. They see the glowing arc of lunar fragments. They see the drifting dust shimmering around Earth. They see the remains of what once guided our tides, our calendars, our stories. The moon is still there, but only in pieces, and the question that haunts them is simple: if the moon can break apart in an instant, what other cosmic surprises still wait in the darkness?